This is your first piece of equipment. This is a volt ohm amp meter, commonly referred to as a digital multimeter. In the past, they were all different devices. You had a voltmeter, an ammeter, and an ohm meter. However, as technology has improved, they're now able to combine all these into one fairly easy to use tool. The reason this is so important is because this measures all of the things needed for Ohm's law, which is one of the most important laws in electronics. It can measure voltage, it can measure current, and it can measure resistance. And with those three things, that's basically what Ohm's law is V equals IR. These come with numerous features. You can get things that auto range and that measures capacitance and inductance and just all sorts of things. Diode testers and transistor testers built into them. All of that stuff costs money. All you really need at this point is a simple means to measure voltage, amperage, and resistance. And that'll get you through the fundamental part. And then when you need more advanced stuff, you're likely going to look at purchasing things like this or this, which are just really advanced versions of this. This stack of equipment here costs considerably more money. This will get you through about 90% of your study of electronics. All of this stuff up here, this other equipment, all of this stuff up here, it's nice to have, and it does different stuff. But even now, when I'm out working on electronics, the tool I use the most is my little $15 multimeter. Like I said, all of these do all kinds of special things. This, for instance, tests how accurate the sidebands are on radio transmitters. This counts frequencies to make sure radio transmitters are centered. This generates radio frequencies so that I can simulate or build radio circuits. I can use this to validate the quality of the signal this is putting out, or the quality of the signal these other transmitters are putting out. But well over 90% of my work uses a simple digital multimeter. So we'll go over how the multimeter works so that you can get started on your electronics. First off, you will have a black lead. Most likely it will be a black lead. These are called banana leads or banana plugs, and they simply just push right in, and that's all it is, just a friction fit. Then you will have a red lead. Now, a multimeter has two places to plug the red lead. You plug it in here for most operations, measuring voltage, volts, ohms, and some of them even allow you to plug in there if in this one lead for low current, which is like under a few amps. Then over here you have an ammeter lead port. Some voltmeters require you to always measure current through this port. Some just require you to measure high current through that port. And I'll explain the difference, reason why in a few minutes. But generally, you always want to leave your red lead in the volt ohm jack. And the reason for that is because the ammeter jack is a what's called a low impedance input, And if you accidentally leave the lead in there, and then you go to measure voltage and you don't move the lead over here, let's say you're putting 5 volts in here, well, that 5 volt is going into a low resistance input, and it can put several amps into that input and exceed the 10 amp max, which will blow the fuse or possibly destroy the meter. So it's always a good practice, if you measure current, move the lead over here, do your measurements, and then immediately move the lead back over here or remove it completely. Because if you just leave it plugged in, you will, and I've done it. In fact, I did it yesterday. I left the lead plugged in, I measured voltage, and guess what? 220 volts can put several million amps out into that impedance and blew up one of these meters. It had a fuse in it, had to replace the fuse, but it's not uncommon to accidentally measure voltage through this port and it will blow the fuse if it's a fused input. If it's not a fused input, it may destroy the meter. So it's always a good practice. The black lead always goes in the black port. The red lead always goes in the volt ohm port, unless you're measuring current. Move it over here, measure your current, then move it back. And that way you don't accidentally measure voltage in this port and blow a fuse. If you have a fused input, carry a few fuses with you, because I still blow that fuse once in a while, even though I try to make it a habit to always move this lead back over here. Most ohm meters or digital multimeters have settings similar to this, and there's a few that have different ones, but anyway, the very basic ones are all the same. So there's you'll learn there's two kinds of basically types of voltages. There's DC voltage and AC voltage, and these multimeters can separate the two. So if you're measuring DC, you can simply turn this over to DC. Any place in this DC side will measure DC voltage. Now, you may notice that that's set to 1000 volts DC. What that means is that this meter will measure up to 1000 volts on that setting. However, you'll notice that there's only 3 digits, so it will measure 1000 volts accurate to about 1 volt. So if you want it more accurate and you're measuring a lower voltage, you can go down to 200 volts, and you'll notice now a decimal place appeared. So now I can measure up to 200 volts to accurate to a tenth of a volt. And if you notice, if I move it again, I now have 2 decimal places of accuracy, but my range, I can now only measure 20 volts. And then if I go down some more, I will get more accuracy, but now I'm limited to what's 2000 M means 2000 millivolts. So my range is down to 2 volts. And then if I go down some more, my range is 0.2 volts. Now when you get to the M, where it says 2000 M, now when it measures, you're no longer measuring volts, you're measuring millivolts. So this will not necessarily, now some voltmeters have a millivolt light that comes on and tells you, but generally whenever you have this marked, it has the little M right there, that means that this is now measuring millivolts, not volts. See, these don't have a mark on them, so we're measuring volts. Here it has a mark, it's measuring millivolts. This one is also measuring millivolts, and you'll notice as I turn this down, lower the range some more, notice a decimal place comes up. So now I'm measuring accurate to 1/10 of a millivolt. The other thing you need to learn about your multimeter is turn it off, because if you forget to turn it off and put it in your toolbox, next time you need to use it, the battery will be dead. And then you won't be able to use it. Such is life. Carry a spare battery with you, because you need these when you're on top of a ladder. You never need them when you're standing by a rack of batteries. So you'll also notice on the other side, you'll see that this says V8 volts AC, and you'll notice that this has a range of 750 volts and a range of 200 volts. Now generally when you're measuring AC, you're measuring fairly high voltages. Again, this voltage is up to 200 volts AC, and this is 750 volts AC. So later you're going to learn that there's different ways to express how AC is measured. The common measurement that's used for power distribution is called RMS, and most voltmeters measure RMS voltage. You'll get a few that measure what's called peak or peak to peak, but generally if it doesn't say, it's measuring RMS voltage, which is what an electrician would use. Peak and peak to peak are different ways of expressing the same thing. However, RMS is generally used for power distribution purposes. And then over here, you will see amps DC. And it starts at 10 amps. Now some voltmeters have this 10 amp input that you can use for measuring current. Some of them, all current is measured through this port. Others have a special range. Some of them have special range ports. So if you're measuring more than 10 amps, like 100 amps, you'll have a 100 amp input. You just have to be sure to match that, because this input is not rated for 10 amps, for more than 10 amps. So if you're measuring 15 amps, you'll blow this. Now this meter only measures 10 amps, but on some meters they measure 100 amps. So you may have special ports for higher amperages. You'll notice again that I'm measuring 10 amps accurate to 2 decimal places. Notice that when I go to 200 M, I am now measuring milliamps because there's an M there. And then this range is similar to voltage. It goes down to 20 milliamps, and then 20 microamps. That little symbol right there is microamps. So now the meter has switched over to microamps, not milliamps. So if you see a 10 up here, it's 10 microamps. If it says 10.9, it is 10.9 microamps because that micro's there. And again, 20 gives you an extra decimal place, but it cuts the range down by 10, and it is also measured in microamps. Then, probably the second most used part of this is the ohm meter part. This measures electrical resistance. Now you'll notice that that has a capital M there, which stands for mega or million ohms. So this will measure up to 20 million ohms. Since that's an M, that's measuring 3.42 mega ohms. Now I do have something hooked up to this right now, so you're getting a reading there, but normally if I were to disconnect this, that will go to, it'll climb and it'll go to that state right there. Now different meters have a different output for what's called over range. What this is saying is you've exceeded the range, the impedance, the resistance you're trying to measure is more than 20 megohms. And it is, because I unplugged the lead here and it's measuring the resistance between this lead, and there's nothing connecting the two now, so the resistance in theory is infinitely high. So no matter what I set this on, it's not going to be able to measure it. So again, if you notice right here, that immediately goes from 20 megohm to 200 or 2000 k ohms, which is basically the same as 2 megohms instead of 20. But notice that this says a K, so now this is measuring k ohms instead of megohms. Again, if I turn it down, I'll get another decimal place of accuracy, but my range is cut down. And again, that's measuring k ohms because there's a K there by the 20. And then when we get down here, we're measuring, there's no symbol beside it, so we're measuring straight ohms. So now the meter's telling how many ohms. Notice it's still in over range because it's still unplugged. And then we can go down to 20 up to 200 ohms. So we can manually range this. I do want to show that this port says unfused. What that means is if I plug this in wrong, it will blow this, most likely. It'll destroy the meter. So if you can, I would get a fused port, but they make them that are fused, and you can, there's a fuse that slides in this port, and if you have an option, I would get that for sure. So that's the basics of a voltmeter. Now this one has a couple of extra features, like if you look right down there, it has a little diode, so you can test to see if diodes are working right. And then this one has, this symbol puts out a digital pulse. I've measured it, it's about 330 hertz. So this will put out a signal. I've never used it. And in fact, until I started making this video, I didn't even know it was there. I had this meter for 20 years, so, or, you know, several years anyway. So for the most part, that's the way a voltmeter works. So what I'm going to do is, I have different test leads for this, but what I'm going to do is I'm turning on my power supply, and I have it hooked to this voltmeter, and I'm going to turn up the voltage, and as you can see, I start measuring. It's now at 5. Now the question is just an exercise on reading your voltmeter. What is that? Well, it says 5, and if I look down there, it's set to 1,000 volts. So there is no symbol next to the 1,000, so it's volts. So I am reading 5 volts. Now I can look on my power supply here, and I can see that it is in fact putting out 5 volts. So if I turn it down to 200, notice that I'm reading 5.1 volts. Now, the other setting said 5 volts, and now this one's saying 5.1. Well, which one's right? Well, they're both right, because this one, remember, only measures accurate to 1 volt. This one measures accurate to 1/10 of a volt. So now I can turn my voltmeter, my power supply down just a little bit. And now it measures 5 volts. Now, if I switch this again down to the 20 volt range, notice that now it says I'm getting 5.01 volts. Well, again, I was only measuring 1 decimal place of accuracy. Now I've got 2 decimal places of accuracy, so I can bump this meter down, this power supply down just a smidgen. Now I've got 5.0 volts. Now then, now comes the problem. I'm going to turn this down again. Now notice I set this to 2,000 millivolts. And look what happened. It went into an out of range state. So I'm putting 5 volts in, but this voltmeter is set to only measure up to 2,000 millivolts, which is 2 volts. So I'm now going to turn this down. And now it's reading 1754. I'm going to turn this down to 1500. It's very sensitive now because now I'm talking about millivolts on my power supply, not volts. So just touching it makes it kind of go goofy. Okay, so now I'm at 1498, and since I'm on a millivolt range, since the little m's there, this is 1498 millivolts. Now again, if I turn this range down again, watch what happens. Bam, over range. The reason is because this only measures 200 millivolts, which is 0.2 volts. So now I've got to turn my power supply down some more. And now I'm down to 171 millivolts. So anyway, that's the way the ranging works on the voltage. So looking at the test leads, this is a very common type connection called a banana plug, and it not only fits in these voltmeters, but it also fits in other equipment like this voltmeter, or this device has banana plug connections. It's pretty common for power supplies to have banana plug connectors on them. Now, there's several different types of these ends. Now, what I've found out, this one has kind of a little rubber boot on the edge of it, so the connector is actually goes in further than that. Now, what I've found out is those little rubber boots, for instance on these, they're not rubber anymore. They over time they turn to like plastic, and they're not flexible. So when you plug these in to these connectors, if you look down in this connector, you'll see this little ring right down in there. Well, the banana plug goes in the center, and that rubber boot goes on the outside of that ring, and it makes kind of a sealed connection. Some people say that those boots are for explosion-proof ratings, but I don't buy that, and the reason I don't buy that is because this meter is not explosion-proof. So why would they put explosion-proof connections on them? Explosion-proof connections are very expensive to get an explosion-proof rating on. So they're more just a dust cover of some kind. But anyway, what I've done is when those things turn to plastic, what'll happen is they will hang up on that little ridge in there, and then they will just wad up, and it'll be hard to get these banana plugs to stay in. I've also found that not all banana plugs accommodate those boots. Mainly on power supplies, for instance, these do not accommodate that boot. So when they start acting up, I just take an X-Acto knife and I just cut a ring around that, take that boot off. Most banana plugs you use on a bench, they don't have that boot. And if you're worried about the explosion-proof thing, then don't use those leads in an environment with explosion dangers. The other problem is these exact same leads, I have another set here, they have the opposite end looks like this, which is not explosion proof. And then they have, where the wire hooks into the lead is also not explosion proof. So that's the reason I don't buy the explosion proof thing. So, but in any case, I've had a lot of trouble with those rubber boots on there, but it is perfectly fine just to cut them off. You're not going to hurt that lead at all. I mean, it's just, it's there for, to keep that contact clean. But so I want to look at a few more little things on voltmeters, and most voltmeters will have this kind of a setup here. So if you look down at the inputs, you will see that this one says 500 volt max. That means you cannot put more than 500 volts on this right here. Now, you will find out that a voltmeter is what's called an isolated device. So I don't have to measure from ground over to hot, measure voltage. I can measure between two different hot voltages and find out what the difference is between those two voltages. So what this is saying is you can do that, but with this particular meter, you can't have this plugged into anything more than 500 volts. And then notice that it has ratings here. Now what this is saying is the difference between these two cannot be more than 1,000 volts or 750 volt AC, and no more than 200 milliamp max between these two. Now that's you'll kind of notice that those are the max ranges up here. This may take more than that, it may not, but it's not designed As a whole unit, it's not designed to do more than 1,000 volts between here and here. I want you to notice there's a 10 amp max on here, and this is an unfused connection, which means if you drive this to 12 amps, you're probably going to destroy the meter. You may destroy the meter. Who knows? But anyway, when this meter's had enough, it will fail. It will not blow a fuse. Then the other thing about your meter is it's got batteries in it, like everybody probably knows. If you use this a lot outside or on the job, bring some spare batteries. But these batteries last forever. The batteries in this one's probably been in here 5 years, and it still works